Let's return to our golden snitch factory from earlier. Remember how the average total cost first dropped from $40 to $4 per snitch when the firm was producing 5 snitches, down to $35 per snitch when it was producing 8? And then it rose when production rose beyond 8 snitches, up to $37 per snitch when the firm was producing 10 snitches? Even though this is a made-up example from the fantasy world of Harry Potter, economists believe that these U-shaped average total cost curves are the norm for firms in real-world industries. The reason is that the average total cost curve reflects 2 competing forces as production increases. First, as production increases, the average fixed cost is falling. Average fixed cost is the fixed cost divided by the quantity of output. Since the fixed cost is the same regardless of production level, as the firm produces more snitches, the average fixed cost falls. We can draw the curve to show how average fixed cost falls as production rises. Average fixed cost is steadily declining, from $40 when the firm is producing 5 snitches to $20 when it's producing 10. Second, as production increases, the average variable cost is rising. Average variable cost is the variable cost divided by the quantity of output. Variable cost is the sum of all the marginal costs. And since we saw earlier that marginal costs rise as production increases, so too will average variable costs rise. As you can see here, marginal costs are rising, and the marginal cost curve is upward sloping. The marginal cost is rising because the marginal product is falling as more and more goods are produced. Average variable cost is also rising, but more slowly than marginal cost, as you can see in the graph. Average variable cost is the average over all the units, so rising marginal cost drags it upward, but more slowly. The average total is just the sum of average fixed cost and average variable cost. Now the reason for the U-shaped average total cost starts to come into focus. On the one hand, the more production, the more units across which to spread fixed costs. Average fixed costs fall, first quickly, then more slowly. On the other hand, the more production, the higher the marginal costs, leading to a higher average variable cost. At low levels of output, the first effect is powerful because even small increases in output cause a large reduction in average fixed cost. So at these production levels, the first effect dominates the second effect and the average total cost falls. But eventually, the second effect overtakes the first effect and the average total cost starts to climb. At the bottom of the U-shaped average total cost curve, these effects exactly balance out. At this point, average total cost is at its minimum level, the minimum average total cost. Note that the marginal cost curve crosses the average cost curve exactly at this point of minimum average total costs. This is not an accident. If marginal costs are rising, and we generally assume they are, the minimum average total cost is where average cost equals marginal cost. This is because average total cost rises more slowly than marginal cost. If average cost is greater than marginal cost, a firm can drive down the average cost by producing more. This has the effect of lowering the average fixed cost more than it increases the average variable cost. If average cost is less than marginal cost, a firm can drive down the average cost by cutting back on production. The average fixed cost will then rise, but not by as much as average variable cost falls, as a result of smaller marginal costs. This is really hard. Unfortunately, you may be required to draw these cost curves from memory on the AP exam, and questions about the relationship between the curves are common. So feel free to go back and review this if you need it. I know I had to. In summary, the total cost curve shows the sum of the fixed cost and the variable cost. The average total cost curve shows the total cost divided by production. The average total cost curve can be decomposed into the average fixed cost curve, which is sloped downward, and the average variable cost curve, which is sloped upwards. The marginal cost curve shows the extra cost for an additional unit of output at each production level. We've assumed that marginal costs are increasing, so this curve would slope upwards. When drawing cost curves, don't forget to have marginal cost curves intersect the average total cost curve at the lowest point on the average total cost curve.